We are solving ISS 2021 paper 2 question number 42. So let x1 is to xn be id with probability density function this. Let x1 is minimum of x1 is to xn and define the class of estimator tx is equal to x1 plus k and k is belonging to R. The estimator that has smallest mean square error is. Okay, so we need to find the estimator that has a smallest mean square error. Okay, so what is MSE first? Okay, so if t is an estimator of parameter theta, then MSE is nothing but is defined like this. MSE of t is this, which is the average distance between the statistic and the square of the average distance between the square of the statistic and the parameter. Okay, so we need to find, so here our statistic is nothing but tx and the t is tx and tx is defined like x1 plus k. So put here, so x1 plus k minus theta. So we are estimating theta here and the density function is e to the power minus x minus theta and x is greater than theta. This is the density function. So let's rewrite like this: x1 minus theta square, x minus theta plus k whole square. Now suppose this is a and this is b. Now apply the a plus b whole square formula. Then it will be expectation of this square plus k square, because expectation of k square constant will be constant. Then minus plus 2k x1 minus theta and expected value of this. So suppose this is m, so we need to minimize it. Okay, so minimize it with respect to k. Okay, so deva m divided deva k will be, so this is independent of k, so this will be 0. Now differentiation of 2k will be k square will be 2k plus 2 into differentiation of this will be 1, and we are left with 2 into expectation of x1 minus theta, 2 into expectation of x1. Now when expectation go inside, expectation of theta will be only theta. Now put it equal to 0 to find the value of k. So k will be, now 2 will cancel out, and we are having theta minus expectation of x1 as the value of k. So at k equal to this value, our MSE is minimum. So to find the value of k, we need to find the expectation of x1. So this is the density function. So density function of the lowest order statistic is given by the formula 1 minus fx to the power n minus 1 into small fx. So in that case the PDF is this. So for this case the distribution function is given by this. Okay, so let's put here, so we will having x minus theta into n minus 1 and the density function, which is e to the power minus x minus theta. Now e to the power n into x minus theta, this is the density function. So we need to calculate expectation of x1. So expectation of x1 will be n into x e to the power minus n x minus theta, differentiation with respect to x, and here the x limit is same as the density limit, which is x greater than theta, means theta to infinity. So there is theta here, so let's assume x minus theta is equal to t and dx will be dt. So limit will be 0 to infinity, and then n x will be t plus theta e to the power minus nt dt. Let's open it, and t to the power, so it is t to the power 1, so we can write like this: 2 minus 1 and e to the power minus nt dt plus 0 to infinity, then theta n e to the power minus nt dt. Now this is the gamma function, so use this. So gamma 2 divided by n square plus theta into, now if you integrate it with respect to 0 comma infinity, then it will be e to the power minus 0 into n. Okay, so I am using here this formula, so let me write if you integrate lambda e to power minus lambda x dx with respect to a to infinity, then answer will be minus e to power minus a lambda. So this is the short formula that you can use. So we having this. So 0 into n will be 0 and e to power 0 will be 1. So n will cancel out. Gamma 2 is 1 by n plus theta. So expectation of x1 is 1 by n plus theta. Now put value of expectation of x1 here. So value of k will be 1 minus n minus theta. So value of k is minus 1 by n. So our class of estimator and defined in the question is x1 plus k, and value of k for which MSE is minimum is minus 1 by n. Let's put it here. So for the estimator x1 minus 1 by n, MSE will be minimum. So let's so option D will be correct.